at AP Review. This is 2011 Form B, AB Free Response 4. Consider the differentiable function f having domain of all positive real numbers, for which it is known that f prime of x equals the quantity 4 minus x times an x to the negative third for x values greater than 0. Part A. Find the x-coordinate of the critical point of f. Notice they said the single critical point of f. Determine whether that point is a relative maximum, a relative minimum, or neither for the function, and justify your answer. For the function of f, justify your answer. So part A. So what it means to be a critical point, right? So a critical point for f means that f prime is 0, f prime doesn't exist, or we have an included endpoint, right? Because an included endpoint would go on our sign chart too. But there are no endpoints here. So we're either looking for f prime is 0, f prime doesn't exist. So f prime equals 0, right? If we set this thing, which is actually a fraction equal to 0, that's a 4 minus x over an x cubed. Well, a function or any sort of thing equals 0 if the top of a fraction is 0, right? So if I multiply this x cubed over, it would disappear. So essentially 0 equals 4 minus x, so x is 4 would be that critical point. Now right away, that's probably my only answer because they specifically said the critical point. But let's just walk through why there isn't another one. F prime does not exist would mean that the denominator of f prime is 0. Well, that would be x cubed equals 0, and x would be 0, but notice that this f prime is only in existence for x values that are greater than 0, so that's not going to be included, right? So my only critical point is at x equals 4. Now to figure out if I have a max, min, or neither, the easy way to do that is to make an f prime sign chart. So I know that I do have an endpoint at 0, right? So technically 0 does show up on my sign chart in the sense that there's nothing before 0 because f prime only exists after 0, right? So I have 0, and I have this other critical number that is 4, right? So we want to know the sign of f prime. There's a couple different ways to do this, right? One easy way to do it is to essentially split f prime into the factors of f prime, which would be this 4 minus x on the top and an x cubed on the bottom, right? So, and then I can figure out based on their signs the sign of f prime, which tells me what f is going to do, right? So 4 minus x is 0 at 4, and because it's a line with a negative slope, it starts out positive, crosses that 0, and becomes negative. So it's going to look like this. The other way to figure that out, honestly, is to plug in a number between 0 and 4, and you'll find that you get a positive in this window, and plug in a number bigger than 4, and you'll find you get a negative. X cubed is going to be positive for any positive number. It would have been 0 at 0, but remember, 0 is a cutoff. We can't do anything across 0. So a positive divided by a negative would come out positive. A negative divided by a positive would come out negative. So what that means is f is going up and then down. So I have a max here for f, right? So they say specifically, give the x-coordinate. So this is the x-coordinate of the only critical point. And then they ask, determine if it's a relative max, relative min, or neither. And in this case, it is a relative max. And then they just say justify your answer. So this is enough work to justify my answer. If they'd said explain, I would have had to explain in words that f prime changes from positive to negative. So I'm going to note, hey, that's a relative max at x equals 4, and if asked to justify my answer, I can point to any of this work with an f prime sign chart. Remember, if you're using sign charts to justify your work, it is super important that you label your sign chart, right? I made it clear that I'm talking about f prime here, and that then I'm talking about f when I talk about the up and down arrows. Cool. Part B. Find all intervals on which the graph of f is concave down, justify your answer. So just like here I started with what's the thing they're asking me, and I translated it to what I need, I'm going to do the same thing with concave down. All right, so for part B, they ask me on the intervals that f, so the thing I am asked is when is f concave down, right? And so the first thing you want to do, and you don't have to write this as a flowchart, but a good sort of rule when dealing with these things is to translate this to the actual definition of what that means. And in this case, that would mean that f double prime is less than 0. So I need to find when f double prime is less than 0. Well, before I can do that, I really need an f double prime. So let's go ahead and do that. So I have that f prime. Now, it's up to you. I'm a big fan of the quotient rule. You can do this as a product, and that's fine. I'm probably going to treat f prime of x as a quotient, as a 4 minus x on top of an x cubed. Again, it's your preference. If you want to treat this as a product and do u and v, that's fine. I'm going to do it this way instead. I'm going to do a high function and a low function when I derive it. So my f prime of x is low, which is x cubed. D high is a negative 1, minus high, which is a 4 minus x. D low is a 3x squared. Draw the line and square the low, which is going to be an x to the 6th. So now I just need to clean up the top and sort out that whole mess, right? So when I clean up the top, this is a negative x cubed, right? And then I'm going to distribute this negative and the 3x squared here, right? So like I'm going to distribute a negative 3x squared. So I end up getting a negative x cubed. When I times this 4 by a negative 3x squared, I get a negative 12x squared, right? And then when I times this negative x by a negative 3x squared, I'm going to get a plus 3x cubed, right? All over an x to the 6th. So I end up getting that this is a 2x cubed minus a 12x squared over an x to the 6th, right? So now I'm going to copy my my f double prime up here so that I can buy myself a little bit more space. I'm going to yank out a 2x squared while I'm at it and have an x minus 6 here all over an x to the 6th, right? So what you'll notice is if I want, since I took that x squared GCF out, I can cancel that with the x to the 6th and make that an x to the 4th on the bottom. So it looks like my f double prime is a 2 times the quantity x minus 6 all over an x to the 4th. Right? So now we should find, I always call these key points. This is what I tell my kids is a Hoganism. Just like you have critical values for the first derivative, right? Critical numbers for the function come from the first derivative. I always say that we could call these key points. Same concept as a critical number. So what we're looking for is when is f double prime equal to 0, which would be when that numerator is 0. Since 2 equals 0 is a lie, I would just look for when x minus 6 is 0, which is at x is 6, right? Or when f double prime doesn't exist, well, that's only going to happen at x to the 4th equals 0, which is x equals 0. And we already know that since the original derivative that we had was not included at 0, this is also not included. So that's actually an endpoint on my table. So really, the other thing I can notice is that x to the 4th is always positive, right? For non-zero x, right? For x is 0, we'd have an issue, which is why this doesn't include 0. But for non-zero x, anything that's not 0, even if it's negative, x to the 4th will come out positive. So really, the sign of f double prime depends entirely on the numerator in this situation. So what's going to happen is that if you look at the sign of the numerator, and you can make a full-on f double prime sign chart if you want, right? If you wanted to, f double prime is a 2, an x minus 6, and this x to the 4th, right? And we know that we have an endpoint at 0, and we have this critical number at 6, right? 2 is always positive. And a sign chart. So 2 is always positive because it's just a 2. X minus 6 is a line with a positive slope, right? So it is negative before it's 0 and positive after. Again, if you want, you could just pick a number between 0 and 6, plug that into x minus 6, and you'd see that you get a negative. And x to the 4th is 0 at 0, which is my endpoint anyway, not included, but positive everywhere else because it's to the 4th power. So my f double prime ends up coming out negative for x values before between 0 and 6, and then positive for x values after 6. But, so that's technically an infinity, if you need to see it. The question was, when is f concave down? Well, f is concave down when f double prime is negative. So my answer is going to be, either you could write this as the parentheses 0 to 6, close the parentheses, or you could write 0 is less than x is less than 6. Those would be the same answer, right? I like parenthetical notation, but I get that that's not necessarily everybody's jam. Cool. On to part... in justifying my answer, I just basically needed to explain that this was when f double prime is negative and show some work to get me there, which I did. I found f double prime, and then there's my answer. Part C. Given that f of 1 is 2, determine the function of f. All right, cool. So we're now going to integrate, right? So the trick is, so when we go to do C, the trick here is that I really need to distribute that x to the negative second. So this binomial doesn't have a power on it, so I can distribute this and make this a 4x to the negative third minus an x to the negative second, right? Because that's a 1, and a 1 plus a negative 3 would be a negative 2, right? So if I integrate to get f prime, when I integrate x to the negative third, I'm going to up the power by 1, which would be negative 2, and divide by the new power. So I'm going to get negative 2 x to the negative second, and I'm going to up the power of the negative 2 to a negative 1 and divide by the new power. So I'm going to get plus an x to the negative first, plus my constant of integration c. So f of x is going to be, and it's up to you, I prefer to write things with, I don't like the negative exponents as much as I would like to have these on the bottom, so I'm going to write a negative 2 over an x squared plus a 1 over an x, and I'm going to go ahead and find, I have f of 1 is 2, yep, so I know that 2 equals negative 2 over 1 plus 1 over 1 plus c, right? So 2 equals negative 2 plus 1, which is negative 1 plus c, so 3 is my c. So my final answer then, if I give myself a little bit of room to write it, I guess we'll go ahead and do that up here, right? So my final answer is f of x equals negative 2 over x squared plus 1 over x plus 3. Or you could write it with the negative exponents. It's up to you. You could make it a negative 2x, a negative second, plus an x, the negative first.